1-92. Write the prime factorization of each of the numbers below. So prime factorization, we need to have prime numbers, and factorization means we're going to break down the numbers into multiplication, so factors. So a list of prime numbers, so 1 is not prime and it's not composite either. 2 is prime because it's made out of 2 times 1 and only that. 3 is also prime because it's made out of 3 times 1. Now 4 is made out of 2 times 2, so it's not prime, the actual number 4, even though we have also 4 times 1. So right now the prime numbers are 2 and 3, and then 5 would be the next prime number because it's made out of 5 and 1. And I hope you can see the pattern. So this is a little review of prime. The next prime number will be 7. So I'm skipping the 6 because 6 is made out of 2 times 3. So our job is to break the numbers into multiplication, or the operation is multiplication, but those numbers are called factors, and we want them to be prime. So I'm going to do example A. So right now we can think of what two numbers, doesn't matter prime or not, makes 24. So you can start from there. So 24, oops. So 24, and if you haven't written that yet, go ahead and pause the video so you could write the numbers down. So it's made out of, I'm just going to pick up two numbers. So 4 times 6 comes to mind. Now if something else comes to mind, you could use that too, as long as those two numbers make 24 when you multiply. Now 4 is not prime, so I'm going to continue splitting into multiplication. Two numbers that I know is 2 and 2. So 2 times 2. Now 2 is prime, so I'm going to stop and circle it. And then 2 is also prime. So right now 4 was broken down into 2 and 2. So your teacher might have used the word like a factoring tree. That's what I'm doing right now. Now when I go to the 6, I'm going to split it into two other numbers that come to mind. So if it's even, you could always divide by 2. So right now it's 2 times 3. Now both 2 and 3 are prime. So now I have 24. Another way I could have written it is, like say 4 times 6, and then 4 is made out of 2 times 2, and 6 is made out of 2 times 3, but we still get those 4 numbers at the end. Now, prime factorization, we could also have with exponents. It's not required here, but if you have done exponents, we have 3 of the 2's, or the 2 repeats 3 times, so I could use exponent, so that's the exponent 3. And then we have times 3 to the first power, but that's not required right now. I just want to make sure you're aware that you could continue. Now I'm going to do, like I said, B, and you guys can try C on your own. So you can either use a factor tree or you could do a list. So any two numbers that come to mind to make 52. To me, I look at the number is even, so I know a 2 is a factor. So I'm going to divide by 2. So I'm going to start with 52 is made out of 2 times 26. Now you could do a long division on the side of the paper. I did it mentally. So it's 2 times 26. Now 2 is prime, so I know I found one of those already. And I'm going to continue with the 26. So what two numbers comes to mind for 26? Again, I'm going to, if nothing comes up, I know the 6 is even number, so it ends with even. So I'm going to multiply. So I know it's 2 times 13. So in case of thinking of multiplication, I can say, well, 26 divided by 2 is 13. So 2 times 13 has to be 26. 2 is prime, so I'm going to stop and circle so I know which one to list. And then 13, so now is it prime or not? So if nothing comes to mind, if it's just 13 times 1, that means 13 is prime. So that will be the end of the prime factorization for this number. So 52 is made out of 2 times 2 times 13, and that's called prime factorization. And earlier, if you have repeats, which we do, we could write them as 2 to the power of 2 times 13 to the power of 1. And again, that's not required, but it's a good way to use exponents even now in 6th grade as well. So try C on your own. Just a suggestion, it ends with a 5, therefore try to divide by 5. So 5 times something will give you 105, and continue until you write it the same way. So the goal is to have those numbers to be prime.